Hi guys, it's Dr. Justin Salvi here, going through a couple of questions from your tutorial on limits and continuity. And here we asked to find this limit over here, if it exists, or show that the limit does not exist. We're looking for the limit as xy approaches 0, 0, the origin, of x squared times y times e to the power of y, all divided by x to the 4 plus 4y squared. Right. We're going to start by showing that it doesn't exist, and remember, to show that a limit doesn't exist, we just have to find two paths, two approaches that yield different limits. So our first one we're going to try is we're going to take the path that approaches along the x-axis. So we're looking approach along the x-axis. Now when we're on the x-axis, we've got that all our y values are equal to 0. So now our limit becomes, instead of xy, we're approaching from x0 along the x-axis, as that approaches 0, 0 of, and also wherever we have a y in our limit, we can replace it with 0. So we end up with x squared times 0 times e to the 0 all over x to the 4 plus 4 0 squared. We can simplify that a little bit. We get the limit as x0 approaches 0, 0 of, right, well, the numerator just becomes 0 and the denominator becomes x to the 4. Right, now 0 divided by anything just about is 0, except 0 divided by 0. So the only thing we've got to worry about is what if this is 0? Can it be 0? Well, no, not really. We're looking at the limit as x approaches 0. So we don't care what happens when x is equal to 0. We're looking at values when x is getting closer and closer to 0. So we know that this is non-zero, and 0 divided by a non-zero number is simply 0. So this is the limit as x0 approaches 0, 0 of 0. Of course, this is just a constant, and the limit of a constant is simply that constant. So this here is equal to 0. So as we approach 0, 0 along the x-axis, we reach a limit of 0. Now, if you were to approach, the next obvious choice would be to try and approach along the y-axis, but because of this factor y here, we would also end up with a limit of 0. And in fact, if you were to try x is equal to y, you would also get a limit of 0. You might start suspecting that actually maybe this limit exists, but don't forget to try approaching along parabola paths, which is exactly what we're going to do here. So we're going to approach along the line y is equal to x squared. Yes, always try x squared, x cubed, maybe even x to the 4. I think there's one example, one exercise that uses. So we're going to approach along the line y is equal to x squared. That means our limit now becomes, instead of xy, we've got x squared. That shows that we're approaching along that line as that approaches 0, 0. And again, in our function, wherever we see a y, we can replace it with x squared. So we get the limit of x squared times x squared times e to the x squared all over x to the 4 plus 4x squared squared. And of course that's equal to, if we simplify things a little bit, the limit as x squared approaches 0, 0 of, we end up with an x to the 4 in the numerator times e to the x squared all over x to the 4 plus 4x squared squared, 4x to the 4. And now you can see why the choice of y is equal to x squared was quite good, because we end up with a whole lot of x to the 4s. And in fact, if we factorize out an x4 from the bottom, we end up with a limit x squared approaches 0, 0 of x to the 4 e to the x squared all over x squared. Oh, we factorize when we get 5. Sorry, not x squared, x to the 4. We've got x to the 4 plus 4x to the 4. That's simply 5x to the 4. And of course, we can cancel the x to the 4s. Why can we cancel them? We've got to make sure they're not 0. Well, they're not 0 because we are looking at the limit as x approaches 0. We don't care what happens when x is equal to 0. We're looking at values near 0 but non-zero. So we can cancel out those x to the 4s quite nicely there. And now, what's very lovely is we have a continuous function divided by 5. We can simply substitute in x is equal to 0. So we end up that this limit is equal to e to the power of 0 squared all over 5, and that of course is equal to 0 squared is 0, and e to the power of 0 is 1, so we end up with 1 over 5. Okay, so what does this tell us? Well, haha, here we've got a limit of 1 over 5 as we approach 0, 0 along the y is equal to x squared. Here we got a limit of 0. These two things are not equal. Therefore, we found two paths with different limits. Therefore, we conclude that the limit as x, y approaches 0, 0 does not exist. So the only tricky thing about this one was that you had to use the line y is equal to x squared. But otherwise, a nice, very standard limit question.